Welcome to day 4 of chapter 8. We're going to be graphing square root and cube root functions. For each of these graphs, we want 3 to 5 exact points, and we'll state the domain and range. So we're going to start out with the parent function of the square root, as well as the parent function for the cube root, and then from there do some transformations, move to the right, move up, reflect, everything that we did with absolute value equations. So to start off, we're going to start with y equals square root of x. You are going to pick your x value. So we want to pick good values, such as 0. If I plug x of 0, x equals 0 into the equation, the square root of 0 is 0. If I plug in 1, the square root of 1 is 1. Now think about it. You would not want to plug in 2 because the square root of 2 is actually a decimal and it's kind of messy. So instead, skip 2. I actually would skip 3, and how about 4? 4, when you plug it in for the square root, you'll get 2. So these are 3 very nice points that I can use. So 0, 0, 1, 1, 4, 2. If we wanted to keep going, we could. The next one I think would be a good value is maybe 9, 3. That is going to be off your graph, but you will get the idea that the graph, well, actually, don't like that. It's going to be a nice curve there. So it kind of looks like half a parabola. That, my dears, is the parent function for square root of x. So everything, let me write out square function. Everything with a square root will have this general shape. Yes, it might be moved to the right or up or flipped the other direction, but this is what a square root function looks like. The domain, as you can tell, is x is greater than or equal to 0. And the y values also are y greater than or equal to 0. You can definitely write that in interval notation if you would like, but this is the basic parent function for the square root of x. Now let's try this next one where we take y equals square root of x, but add 1 to it. Okay, let's try some values. So what if I plug in 0? That's always a good one. 0 squared is 0 plus 1 is 1. If I plug in 1, square root of 1 is 1 plus 1 is 2. Again, be smart about it. My next good value would probably be 4. You get 2 plus 1 is 3. So these would be the points that I would choose. 0, 1, 1, 2, 4, 3. Again, we can see that curvy shape coming into play if we kept going with our points. Notice the only thing that changes, our domain is the same, but our range actually goes up by 1. Which should make sense, my dears, because of this plus 1 right here. Notice it's outside of the square root. That plus 1 is going to tell me to move everything up 1 unit. Now really quickly, if I'm looking at these functions, I want to make sure nothing's happening on the left side. Right, we want to make sure that our graph actually starts at 0, 1 and only goes to the right. So to do so, I can try a negative number. Let's say I try to plug in negative 1. Well, right off the bat, square root of negative 1 is imaginary. It's not possible. So that's how I can double check that it's going in the right direction and that there's no other points to the left. Okay, moving on to a couple more. Same idea. We're going to keep that parent function idea, but we're going to do a little transformation. We're going to start with some points to pick. This time, let's see. If I plug in, again, I'm just picking points. If I plug in 0, 0 minus 3 is -3. I can't take the square root of -3. So that's actually not applicable, not an option of my graph. Oh, what if I pick 3? 3 would be a good number because 3 minus 3 is 0. 0 minus 2 is -2. If I plug in 4, you will get -1. And if I plug in, again, picking a good value, you want a nice square root under there. So how about 7? 7 minus 3, 4. Square root of 4 is 2. 2 minus 2 is 0. Again, you have the choices of where you start. So when I graph that, it would be 3, -2, 4, -1, 7, 0. We know the general shape is that nice curve. And if I needed some more points to see the shape, you graph some more points. Now let's be smart about this. What would this -2 do? Well, that's telling you move everything down 2 units. Did I move my parent function down 2 units? You bet your bottom dollar. What does this -3 inside the square root actually do? Well, think about absolute values. You actually go to the right 3. You do the opposite of that operation. That gives you this starting point. 3, -2 is created because of those two values in the equation. Pretty cool. So domain x is greater than or equal to 3. That's my x values. And y is greater than or equal to 2. Okay. One more square root function. You can look at this in many different ways. Sometimes people think it's helpful to rewrite it. If you want to rewrite it as square root negative x minus 3, that's helpful for some of you. If you want to leave it though, that's fine too. The biggest thing is you are being able to choose your x values, so whatever way works best for you. So thinking of some x values to choose. How about 0? If I did 0, 0 minus 3 is -3, but times a negative outside, you get 3. But I have to do the square root of 3. That's a decimal. So not a good point to pick. If I don't have to pick that point, maybe I won't. So think of other ones, maybe like -6. -6 minus 3 is -9. -9 times -1 is +9. So square root of 9 is 3. That's a very nice value to pick. Maybe try to pick some positive. Maybe 2. You'll get 1. 3, you'll get 0. And let's try maybe one more, 4. 4 minus 3 is 1. Ooh, but times a -1, that gets you a negative under the square root. So I know I can't go any further. Let's see if this gives us a good shape. So 3, 0, 2, 1, -6, 3. I mean, I see the curve, boop, boop, but it's just going in a different direction. That happens, right? We've learned about that with our absolute value. This negative sign right here is actually flipping over the y-axis. As always, this negative sign is telling us to go the opposite direction. And then you have your graph. You may use the equation to help you. All right, reflect over y And you have your XY points to verify. So if I looked at domain this time, it's x is less than or equal to 3. And the range is y is greater than or equal to 0. Notice the point that my little green notifications gave us was the starting point 3, 0. Okay, so that is the basic idea with square roots. You're going to use the parent and then move it up around town using a nice XY table to help you verify. Moving on now to our cube root functions. Again, we're going to start with our parent and then move everything around from there. So with this, I'm going to write it now already that it's the parent. We have a little bit more freedom with our cube roots because you can have a negative value underneath a cube root and still have a real answer. Kind of cool. So what if I pick 0, always a good value. Cube root of 0 is 0. 1, cube root of 1 is 1. And then would you want to pick 2? Would you want to do the cube root of 2? No. I'll give you a decimal. So instead, pick a good value, maybe 8. Cube root of 8 is 2. But since I have a cube root, I can plug in some negatives. So what if I plug in negative 1? Cube root of negative 1 is negative 1. Cube root of negative 8 is negative 2. Let's graph it and get the idea of what it's going to look like. So we have 0, 0, 1, 1, negative 1, 1. I'm like, oh, maybe it's linear. But you don't fall for the trap. You keep graphing. You need more points to verify. And if you look, these are the next 2 points, and you're right away like, no way is that linear. Right? It actually looks like that. Sorry, that was a little weird at the beginning. But it's kind of a squiggle. That's a cube root. That's the parent function of the cube root. The domain is all reals. It will go on forever. And the range is all reals. It's going to go on forever. We're now going to take this parent function and just apply some transformations. So for example, let's do this y equals cube root of x plus 2 minus 1. Well, thinking about what we know, this negative 1 is going to tell us to go down 1. This plus 2 is actually going to go to the left 2. And that might help me pick some points right off the bat. I think my first point I'm going to choose is negative 2. And hopefully I get out negative 1. Left 2, down 1. So if I plug in negative 2, plus 2 is 0. 0 minus 1, negative 1. Another good idea is to pick a point to the right, to the left. So negative 1 and negative 3 would be my next ideas. If you plug in negative 1, you should get 0. If you plug in negative 3, you should get negative 2. And then I need to pick one more value a little bit further out so that I can see the true shape. So thinking of a good number for a cube root of 8 is a good number. So in order to get an 8 underneath the cube root, my x should be 6. 6 plus 2 is 8. There's my cube root. You'll get out 1. And also you want to get maybe the cube root of negative 8. So if x is negative 10 plus 2 is negative 8. Love how that works out. And then you get negative 3 as the y value. So let's graph this. Oh, golly, it falls off the graph. I think we should scale. Right, you want to scale it. You don't want to have a weird looking graph. So if we want to scale, maybe scale by 2s. Maybe scale by 2 in the x's. This is not ideal, guys, but it's okay. We'll power through. So negative 10, 2, 4, 6, 8, 10. I'm still going to go the y's by negative 3, though. Negative 3, negative 2, negative 2, negative 1, negative 1, 0. Okay, so doing so, you do see your nice curved shape. Based on just looking at the equation, you know that it goes left 2, down 1, so the new middle point is negative 2, negative 1. Like always still, the domain is all reals, the range is all reals. Last one we have for our cube root. We want to pick some good values. You want a nice cube roots underneath. So you might want to get maybe negative 8 under the cube root. We know negative cube root of negative 8. So if I plug negative 7 in, I would get negative 8 under the cube root, which would be negative 2. But there's a negative sign in front. So that's telling me 2. Pick some more values. 0 might be a good one. I actually want to look at this, and if I see that negative sign inside the cube root, I know that's to the right 1. So maybe a good point to pick is 1. 1 minus 1 is 0, so that's really nice. And then maybe just a couple more points. Okay, you only need 3 to 5. For these, I really suggest having 5 just so that you don't think it's a linear line in the middle. Okay, so let's graph these again. We have to scale. So I'm going to scale by 2 in my x's. You have to write that down, otherwise your graph will be incorrect if you tried to graph this. So negative 7. 2, 4, 6, 7 is negative, it was positive 2, I'm sorry. 0, 1, 1, 0. Remember, I'm scaling by 2's. 2, negative 1, and 9, negative 2. Okay, I still see that curvy shape, so that's good. But hey, it's flipped in the other direction. That's what this negative sign does. Okay, it's actually reflecting it over the y-axis, just like it did before in the square root. So it's cool to see that the green information helps you figure out the shape, and the XY table confirms it. Still, because of the arrows, it's all reals and all reals for the range. That is now your cube root function. Now we have 2 special ones down. Oh, I'm so sorry. 2 special ones down here. I'm going to get you started on these, and we're going to notice that they're a little different. So when I go to pick values, like I've been saying, you want nice values. So if I pick 0, well, 0 squared is 0, minus 9 is negative 9. Well, I can't take the square root of a negative. So that one actually doesn't work. If I picked 1, 1 squared minus 9 is negative 8. That still doesn't work. As you go forward, you'll see the first value that works in the positive direction is actually 3. 3 squared is 9. 9 minus 9 is 0. Pick another good value. 4 probably wouldn't be that good. Maybe 5. If I plug in 5, I'll get out 4. So you might be thinking, okay, 3, 0, I can graph that. 5, I can graph that. To get more points, you would pick some more as you go. But then, having a square under the square root should be bringing up some questions. So because of this square here, we're going to have to do something special. So yes, that is part of the graph 100%, but you also have to think about the square root. The restrictions for a square root is that it has to be greater than or equal to 0, right? The stuff underneath. So what if I just took what's underneath and made it greater than or equal to 0? That gives me x squared greater than or equal to 9. And for our purposes, I think it's actually easier to think of it like an equal sign first. You'll see what I mean in a second. When you take the square root of both sides, you get x equals plus or minus 3. These are your key points, right? It's not saying these are the only values that work, but these are the points if I did maybe a nice number line, -3 and 3. Those are the key points that it's a true statement. Well, you also have the inequality. So let's pick a point in between. How would I pick the point 0? Well, I actually already did that up here, remember? 0 squared is 0 minus 9. I get a negative number. So right here, I'm actually just going to put a sad face like, oh, sad. It doesn't work. It's a negative under the square root. Boo-hoo. Pick a value in this range. How about 5? Oh, look it. I did that. I got 4. Is 4 greater than 0? It is. Happy face. What about a value down here? What about like -4? Well, -4 squared is 16. 16 minus 9 is positive. So happy face. So this is also a way to help you find domain. Like, where can I be picking points from? Because the graph is not only this curve here, but it also has some values in the range -infinity to -3. What about if we plug in -3? You should get 0. If I plug in -5, you should get 4. So that's helping us realize that the graph actually looks like so. Those are nice curves coming out based on our interval and based on our XY table. Kind of cool, right? All because of the square root underneath, the square underneath the square root. So domain, really quickly, x is less than or equal to -3, or x is greater than or equal to 3, and your range for both is greater than or equal to 0. Okay, so I really suggest whenever you see a square under a square root, plug in this inequality, and let's see what comes out. You try the next one, and then we'll compare answers. Let's see how you did. So the first thing, you have a square under the square root. So you're going to want to plug into the inequality. You want to make sure that it's greater than or equal to 0. Otherwise, you'll be stuck with imaginary answers. So you do so, and you get your key points of positive and -3, which gives you an idea of values that you can start plugging in. So you try some values. Maybe you tried plugging in 0. 9 minus 0 squared is 9. That is positive. Happy face. If you tried plugging in other numbers, maybe over here you plugged in 4, maybe you plugged in -5, those values will not give a true statement here. So that means it's not part of your domain, which helps you when you pick points. You could be picking points for days if you didn't have this idea of where the points should come from. So I picked a couple points, as you can see, -3, 0, and 3. Found the corresponding y values. And now that is the shape I get. -3 less than or equal to x less than or equal to 3. And the range is actually just 0 to 3. So just because you have those square roots underneath does not mean we necessarily know the shape. But here we know that with the squares underneath, it either opens out or it opens like a little half circle. Again, XY tables are your friends. If you have questions, please bring them to class. But this is your video about graphing. Have a good day, guys.